Okay, so I'm just going to take a few minutes to do question B from that extra review that's posted at the bottom. And these are just 4 graphs. This is the sheet. All 4 of these questions is the extent of the sheet. And it just wants you to produce each of the graphs. I'm going to do B because B is kind of like unique in the sense that you can see how it is different. And if you can't, I'll just tell you. The degree of the denominator is less than the degree of the numerator. Okay? So we would have seen that now this lends itself nicely to being long divided, which would have meant that now that we have an oblique asymptote, or what we call like a slanted asymptote. Okay, so we need to do a number of different things that makes this different than some of the other questions that are in the review, including finding said equation of the slanted asymptote, as well as factoring the numerator, so that I can see if any factors cancel from numerator to denominator. Okay, so this is a pretty extensive question. It's going to probably be a little bit longer of a video, but I'm going to take you through all the steps required to get to be able to graph this question fully. Okay, so first things first, it starts like usual. I think we're just going to probably try and state, find any asymptotes. It's just complicated by the fact that like the denominator is now less than the numerator. So I'm going to say there's no horizontal asymptote here, right? We'll start off the bat with that. No horizontal asymptote. I'm just going to decrease the size of that. No horizontal asymptote for this problem. Okay. We have an oblique asymptote. Okay, and I'm going to caution you to say whether or not that we have vertical asymptotes. We're going to classify them first, okay? So there's 1, 2, vertical asymptotes, unsure yet. I think there's probably going to be at least one, but I'm going to classify for a moment restrictions, and the restrictions are, I will further classify in a minute. The restrictions are, or do come from the fact that x squared minus x can't equal 0. Okay, so I'm just going to say x times x minus 1 can't be equal to 0. So x can't equal 0 and x minus 1 can't equal 0. And so x can't equal 1. I'm just going to leave those there for a second as restrictions. We can further classify them later as either being vertical asymptotes or holes. I can't at the moment determine exactly if they're both vertical asymptotes or if there's the presence of a hole. I need to remember the hole exists if I can cancel a factor from the numerator. Okay, and I can't see that at the moment because I've got this big jumbled like cubic equation in the numerator. So I'm going to have to factor the numerator to do a couple of things. A, find x-intercepts, as well as is one of the factors in the numerator either 0 or 1. And it will cancel out with the denominator and we'll get a hole at that x value. Okay, so we're going to run through all this work and just see if we can, produce the graph by the end. But I think the first thing I'm going to do here is just find what the oblique asymptote is. Okay, so I'm going to go through that work. Okay, and to do that, I am going to, what we said before, long divide the quotient, or sorry, the denominator into the numerator. The quotient's what we get after we do that work. Okay, so 5x cubed minus 16x squared plus 13x minus 2. Okay, so we start off recalling x squared into 5x cubed. That gives me 5x. So I'm going to write 5x over here with the linear term. Okay, and then I'm going to back distribute to fill in the underneath the originally like numerator. Okay, so 5x times x squared is going to be, and remember I'm subtracting 5x cubed, okay, and then 5x times negative x is going to be negative 5x squared. Okay, you're going to do the subtraction, so you're going to get 0x cubes. And then 16 take away negative 5 is going to be negative 11x squareds. And then I'm going to drop the 13x down. And then I'm going to start over again. Okay, and now I'm going to go, well, let's see if I can go like the blue into the blue. Okay, and I'm going to be left with x squared into negative 11x squared is going to be minus 11. And then I'm going to back distribute again and fill out the denominator. So minus negative 11x squared plus, because it's negative times negative 11x. So you can see this is a pretty big question and lots of opportunity to make little small errors that's going to ultimately impact your graph, right? So you just got to be really careful at each of these steps. This is now 13 take away 11 x's is going to be 2x. Bring that minus 2 down. There's your remainder there, okay? And so I basically have an oblique asymptote, or the equation of the oblique asymptote is going to be y is equal to 5x minus 11 plus the remainder 2x minus 2 over what the original divisor was, so x squared minus x, okay? So there's your equation, okay? And you guys know, so if I put in bigger and bigger values of x, we talked about this in class, this remainder that I have over here on the side is going to fall off. So you can imagine if I put in like 2 times 100,000 minus 2 over, you know, look at this, 100,000 squared minus 100,000. Like this is starting to look like 0. Right? And so it falls off with time. Is like it's again predicting the end behavior of the graph. So as I go out to both positive infinity and negative infinity, the y values start to look like the y values of this thing. Okay, as I put in bigger and bigger values for the reasoning of this. Okay, so not too worried about the remainder in the long run, although it is still a component of the oblique asymptote. Okay, so I'm going to go up to my graph, and albeit my graph is just a little bit too small to accommodate this oblique asymptote, but we'll be okay. So the oblique asymptote is going to have a y-intercept at negative 11, so down here. Okay, somewhere up in and around here. And then it's going to go up 5, right 1. 1, 2, 3, 4, 5, right 1. 1, 2, 3, 4, 5, right 1. Up to 3, right 1, and so on. Okay, once you get a few of those points, it's good. Okay, and so there's a part of the question complete there, right? Where I've got this oblique asymptote, y equals 5x minus 11. It is an asymptote. It requires an equation. The equation is 5x minus 11. It is also equally a part of this graph. Again, it's like laying out the geography of the graph. You must put it on there and label it as such, okay? So that takes care of a big piece of the graph. Now I'm into the position of trying to figure out, are there any x-intercepts, y-intercepts, vertical asymptotes, all of that stuff, right? And so the next step here, I think, would be to figure out, are there like x-intercepts, right? And so to figure out the x-intercepts, you will recall that the x-intercepts are going to come from the numerator, okay? And had it been a quadratic, I would have just been straightforward enough just to factor the thing, okay? But what I need to do is actually just factor, like I'd say this is going to kind of be step 2. So factor numerator. Okay, and to do that, we're going to use the factor theorem from the first unit. And I'm looking to see, you know, f at some value, like let's say plus minus 1 or plus minus 2. Those numbers came from, remember it could be a d value in this problem, right? The constant term anyway. Okay, I'm going to try and see which of those values gives me a 0. Okay, and so if I were to try, like let's say if I evaluated f at, like -1. Let's just see what happens. Okay, I'm going to get 5 times -1 cubed minus 16 times -1 squared plus 13 times -1 and then minus 2. So if I actually evaluated that and I figured all that out, it would be 5 minus, that should be -5 minus 16 minus 13 minus 2. Okay, which ends up coming out to be, like, let's say -36, something like that. Not quite. It's negative nonetheless. And also the point here is it's not 0. Okay, so that means -1 not a factor. So let's try another one. F at, let's say, 1. That's going to be 5 times 1 cubed plus, or sorry, minus 16 times 1. Let's move this over a little bit and run out of room. Or maybe not. Yeah, maybe not. We'll leave it there. Plus 13 times 1, and then plus 2. Or sorry, minus 2 at the end. So that's going to give me F at 1 is going to be 5 minus 16 plus 13 minus 2. Oh, look at that. F at 1 equals 0. So that means at the value x equals 1, I get 0, which means x minus 1 is a factor. Okay? And so if I were trying to build this out, I'd have an x minus 1 multiplied by something else over here, right? Some quadratic, whatever that quadratic might be. That's what I'm about to figure out, right? So now I'm going to synthetically divide x minus 1. Okay, so basically I'm going to put in, well, x minus 1 is a factor, so I'm going to go synthetically divide 1 into my equation. So the coefficients, so the coefficients of each of the terms, right? So 5, negative 16, 13, and negative 2. That's 5. 1 times 5 is going to be 5. That's going to be negative 11. 1 times negative 11 is going to be negative 11. Add. That's going to be 2. 1 times 2 is going to be 2. Add them. You get 0 remainder, sure enough. Okay? So that means I'm going to have x minus 1 multiplied by 5x squared minus 11x plus 2. Okay? Over, I'll just rewrite the equation right now. And I can factor the denominator to be x times x minus 1. Oh, look at that. Okay? This is f of x. So I'm building it out. So now I can actually see, I can classify the restrictions here actually, right? So you can see an x minus 1 drops out, which means at x equals 1, there's a hole, right? And this is a vertical asymptote. Okay, so in a minute, we'll find the actual location of the hole. That'll just be like in a part of like all the points we end up finding. But for the moment, I now know that I have a vertical asymptote at x equals 0. Okay. So let's continue. So now I can factor the other piece here, right? I'm just going to leave the x minus 1 there for a sec. Oh no, I guess I'll simplify the equation. So now we're going to be left with, I need two numbers to multiply to 10 and add to negative 11. That's 5 and, oh no, 1 sec. It's not going to be 5. It's going to be some combination of 1 and 10. And they both are going to have to actually be negative here. Okay? Now, this is a complex trinomial. You can't just go x minus 1 times x minus 10. That's not going to give you 5x squared minus 11x plus 2. So you actually need to use decomposition. So 5x squared minus 10x. So you're decomposing the 11x in the middle. Okay? Minus 10x minus an x plus 2 over x. Okay, and then you could factor by grouping. And so you have 5x times x minus 2. Factor out a negative 1 minus 1, x minus 2 over x. And then you can factor out the x minus 2. So x minus 2 times 5x minus 1 over x. And so you can see here now, you have, from this equation, this is our simplified expression, right? Where I've lost the x minus 1s. I get a vertical asymptote at x equals 0. Oh boy, we're running out of room here on the side. X equals 0. And additionally, I get that x, so I was looking for x-intercepts here. You know, that's where y is equal to 0. So I'd set the equation equal to 0, and I would get the numerator, right? So I'd get this whole thing is equal to 0. Then this x term would slide up here, be canceled out by the 0 on the left. So that's why we say the numerator's just got the x-intercept. So you could say x minus 2 is equal to 0, and 5x minus 1 is equal to 0. Okay, sorry, I'm running out of room. Okay, and so that means x is equal to 2. That would be one of your x-intercepts. And x is equal to 1/5. That would be the other one, right? And so if I go put that on there, 2 happens right here. Maybe I'll do the actual graph in blue so you guys can see. 2, 0 is 1. And then 1/5 is going to be down in here somewhere. So I'm pretty confident that the graph is going to do something like this. It's going to come down the vertical asymptote. We can't cross the vertical asymptote as per usual. I don't know how far down it's going to come, but it's going to swing back up and go up here. Okay. And then the only other thing that I'm left to have to figure out now is where's the graph on the left side of 0. Okay. So sorry, this is going to probably be a little tight. Again, I probably should have had a different grid or something, but so I'd be now looking for where's the graph on the left side of 0. Okay, so what happens if I put in something like, if I evaluated the function at f at negative 0.5? Like, what do I get? I'm going to use the simplified expression there too, right? So negative 0.5 minus 2. I might actually care about the actual numerical answer here this time. 5 times negative 0.5 minus 1, all divided by negative 0.5. Okay, so if I actually type that all in, and I'll do that with you now, we're going to get some y value. I'm going to plot that y value on the graph, and I'm going to get an idea as to where the graph's actually going to be. So let's put some brackets into the calculator. 0.5 negative minus 2. Okay, so if I do the numerator here, we're going to get negative 6.25, and then I'm going to divide that by 0.5, negative 0.5. It'll be negative 12.5. Okay, so somewhere down in the, no, that could be a little bit off, but it's going to be down in here somewhere. Okay. I may have done that calculation. I've only got my phone calculator here. Okay. So something in the numerator, it's going to be down in here somewhere. Okay. And then for the same reason as the top half, it's going to come up here and come back down again. Okay. So, pretty loaded question. Oh, also, we did not find the location of the hole. That's the last piece. So, I need to find the location of that hole. And the hole occurred at when x equals, what did we say? 1. So to figure that out, we're going to go same thing. So f at 1, or simplified expression, we're going to go 1 minus 2 times 5 times 1 minus 1 over 1. And so we're going to get negative 1 multiplied by 4 over 1. And so we actually get a hole when x is equal to 1. We get a hole at negative 4. Okay, so there's the location of our hole. So I'm going to go put that on the graph. 1 and negative 4 is going to be right there. I'm going to put a hole. Okay, and in the middle, it can't go through that point. Okay, so you can see there. That's pretty much it for this problem. I can also state like maybe the domain, asymptotes, end behaviors, and we can talk about end behaviors too. So as x, this is a very loaded question, end behaviors. So as x goes to infinity, right? So as I put in big values of x, you can see the graph's going up and up in the y. So y is going to go to positive infinity. And as x goes to negative infinity, so as I go out this way, y is also going down, right? So I'm going to get, as x goes to negative infinity, y goes to negative infinity, okay? And the acceptable domain. Okay, so the domain, and I think the last part of this problem is going to be x can be everything, all parts of the real numbers, except x can't equal our vertical asymptote at 0, as well as where our hole is at 1. And I do believe that is the end of this problem. There are no y-intercepts. We did not talk about that. No y-intercepts, and there are no y-intercepts because we have a vertical asymptote. We have a vertical asymptote at x equals 0 or our y-axis. Okay. Pretty loaded question. Lots going on there. I apologize for the one little calculation. It's just that you're going to type this in your calculator. I think I just did that incorrectly with my phone. So you're going to get some negative number, and it's going to be, I'm going to guess, somewhere in and around here. It might be in I think it was just a little bit off. It might have been down in the 15 area. I just typed it in wrong. But in any event, that's what that graph, the blue is going to be kind of what the graph would have looked like. You have your red vertical asymptote and your black oblique asymptote. Everything should be labeled. You know, you're going to put x and y on there. That's pretty much it. I would say that's probably the hardest question in that grouping of 4 there. Lots of information to find out. Some of the information is kind of tricky to find, given that you have to pull on some skills from before with the long division and synthetic division and using factor theorem. Okay, so that's it. Pretty loaded question. If you have any questions, you can drop them in the comments.